Hey guys, Jake here, coming at you with another math lesson today. Today we're going to be talking about coterminal angles, what they are, how to do a problem that involves them, all that kind of good stuff. So if you're unsure about coterminal angles or just want to learn a little bit more about them, be sure to stick around to the end of this video. I promise you're going to be feeling a lot better about them. So let's just jump right into it here. What is a coterminal angle? And again, I've been kind of touching on this. I really want to take kind of a dive into understanding math textbook terminology. So here's a great example. Coterminal angles, here's a definition, a math textbook type definition. Two angles are coterminal if they have the same initial and terminal sides. Sounds confusing just right off that first sentence, but let's see what, it kind of continues to explain a little bit more. For instance, the angles 0 and 2 pi are coterminal, as are the angles pi over 6 and 13 pi over 6. Then to take it a step further, it says as are pi over 6 and pi over 6 plus 2n pi, where n is an integer. So what is all this saying? Basically, if you have any two angles, which keep in mind, this is all in radians. So if you're not very comfortable with how radians work, if you kind of default to thinking about these different problems in terms of degrees, and maybe you even have to translate radians to degrees before you can start working with the problem, I would definitely recommend starting to get a little bit more comfortable with radians. Referring back to your unit circle and memorizing both the degree and the radian measure for all those significant angles on the unit circle. It's going to save you time in the long run because you don't have to go through that mental hurdle of kind of translating between the two every time you have one of these. But keep in mind, this is all written in radians right here. So basically, it's kind of describing here, we need the initial and the terminal sides to be the same for two angles to be considered coterminal. It then goes on to give a couple of nice little explanations here. 0 and 2 pi are two coterminal angles, pi over 6 and 13 pi over 6. And then it even says pi over 6 and pi over 6 plus 2n pi. So if n is an integer, that means n is just a whole number, right? So for any whole number n, it could be positive or negative. So if n is 1, 2, 3, 10, 16, negative 22, negative a million, for any whole number n, if you have 2 times that whole number times pi, and you add that to the initial angle that you started with, you end up with a coterminal angle. So in other words, if you have an angle, for example, we want to determine two coterminal angles, one positive and one negative, for this given angle. We want to give our answer in radians. So we have this angle here, 5 pi over 6. If we want to find coterminal angles, you can basically think of a circle. A full circle has 2 pi radians. So 2 pi is essentially one lap around a circle. One full lap is 2 pi. One full rotation is 2 pi. So if we were to start at this angle right here and take one full rotation around back to the same place we started, that gives us another kind of position in our rotation, which gives us a coterminal angle. So essentially, if you want to find any coterminal angle between one point or one radian and another radian, all you have to do is just add 2 pi. If you take an initial angle, 5 pi over 6, and add 2 pi, that gives you a coterminal angle. Then you could add 2 pi again. So this would be like we just have an n of 2, right? So we have our integer n is 2. We've essentially added 2 pi twice. So essentially this n is just telling you how many times you're adding 2 pi to the initial angle that you started with. And that could be negative 2. So you could subtract 2 pi. We could take our initial starting angle of 5 pi over 6 and subtract 2 pi, and then subtract 2 pi again, and then subtract 2 pi again. We can keep doing it in, as many times as we need to. If we wanted to come up with 100 coterminal angles here, we could just add 2 pi. There's one coterminal angle. Add 2 pi again. There's another coterminal angle. Add 2 pi again. There's another coterminal angle. And just keep on going. However many of them you need, there you go. So really, if we want to find two coterminal angles, one positive, one negative, what I would do is just add 2 pi to get your positive 1 and subtract 2 pi to get 1. So if we want to add 2 pi to this, keep in mind to add two fractions, you need to make sure they get a like denominator. So we need to get this in sixths. So 2 pi, we need to convert that into some fraction with 6 as the denominator. So we would just multiply multiply 2 pi by 6 and put it over 6. So that gives us 12 pi over 6. And then same thing here, if we want to subtract, we would do minus 12 pi over 6. So our two coterminal angles in this case would be 5 pi plus 12 pi would be 17 pi over 6, and 5 pi minus 12 pi would be negative 7 pi over 6. It's not a very pretty pi, but hopefully you get the idea. Negative 7 pi over 6 and 17 pi over 6. So those would be your two coterminal angles, one positive, one negative. So if you haven't already, be sure to go check out jakesmathlessons.com/precalculus-study-guide or scan this QR code. I promise you that thing is going to save you a ton of time as you study for tests and do your homework in any pre-calculus class. So go check that out. And if you want to keep this brain train rolling, just go click on that video right up there. I'm sure you're going to get some use out of that one too. Thanks, and see you next time.